welcome to SanfordFlipMath. This is AP Calculus. We are working, continuing to work from the Finney, Demana, Kennedy book for calculus. We are wrapping up chapter 6. This is section 6.5. We were talking about partial fractions. All right, so the short version is that we have been playing with lots of techniques for doing antiderivative. And those techniques include everything from just doing a straight up antiderivative to maybe doing a little bit of algebra so we can do a straight up antiderivative, to U substitution where we make a little replacement so we can do a regular antiderivative, and even parts, which is kind of like the product rule when you don't really have a function inside of a function. Well, there's another situation that is coming up that we're going to call partial fractions, and basically the idea is when you can split up a fraction into two fractions and even kind of split up the denominator. So that's where we're going, and I want to first do a tiny bit of groundwork talking about why you can't do what we've been doing. Okay, so this first one is actually something we've already kind of done, and here's the idea that if you notice the denominator can be factored, and then once you factor that denominator, that divides out, and then this is pretty much a normal antiderivative. It technically is a little U substitution, and I'm not going to spend time doing that problem, but if you'd like it, here it is. So just hit pause right now because we're going to keep moving. I'm not going to do that problem since we've already talked about how to do that problem. Okay, so if that was too quick, just pop back. Okay, next up, this problem, the second problem, if you notice, this denominator is actually, if I do the derivative of it, so like if I take just a second and say x squared minus 4x is u, then du dx is 2x minus 4, which may not be obvious, but this is actually 2 times that numerator. So what we have here is a situation where we have a 1 over u, or I'll say x minus 2 over u times du over, whoop, that was kind of funny, there's an extra x in there, sorry about that. Just kind of get that out of there. Okay, and then things will divide out, and this becomes now a normal U substitution problem, also with logarithms. So here's that problem done all the way to the end. And again, if you want to, take a look at more detail here, hit pause, and it'll stay there for you, and then it'll disappear. Okay, so again, if that was too quick, go back just a couple seconds. So where we're really going to go with this is this next one, which this one doesn't work like that. I can't factor something. I can still factor out an x from the denominator like I've done in the last, in the very first one, but it's going to have x minus 4 and x. Nothing's going to divide out. It's also true that the denominator, if I treat that like U substitution, there's no way that the numerator is going to be a factor of that denominator or part of that denominator, that it's not going to be part of the derivative, sorry. So remember, for U substitution, you need a function inside of a function. Okay, this kind of looks like that, 1 over something. But the derivative has to be there, so I would need a 2x minus 4 present in the problem somehow. It could be an x minus 2, could be some other multiple of x minus 2. Okay, so what we're going to do instead is we're going to take this fraction apart. First, let me remind you again that this is what it's looking like right now. And ultimately, what we're going to do is take it apart, and we're going to do something over x plus something over x minus 4. And that's the new thing. So this is partial fractions, and this is the idea that we can break up a fraction into the factors of its denominator will create new denominators. And it's kind of like reversing adding up fractions and then getting a common denominator, putting them together, and then reducing. It's like reversing that process. Okay. So what I'd like to do is just kind of focus in on just that fraction for a minute. Okay, so this is that same fraction from the inside. Okay, so this is, again, x minus 2 over, and here's the goal. And what we're going to do is find out what goes on the top for a and b. Now, a quick little note, the degree of the numerator, okay, degree of numerator, must be less than the degree of the denominator. If it's not, then you have to do a division, and we'll do at least one example like that. Okay, so quick little note to self. All right, so what we're going to do is I want to grab this much of it, and we're going to do some work on it. And that's the magic of video. Okay, our goal is to find a and b. So I'm going to get rid of the denominators by multiplying both sides so that we can divide some stuff out. So that's going to be gone. And on the right as well. Now, when I do this over here, x is going to divide out with this x, leaving a times x minus 4 plus, now when I do that here, x minus 4 is going to divide out with that x minus 4, leaving bx. Okay, and on the left side, I'm going to have x minus 2. Okay. Okay, so this is where the sneaky part comes in. So what we're going to do, again, keep in mind the goal is to find out what a is and what b is, and I have an x in there, and I have too many variables flying around. So what I'm going to do is I'm going to pick a value for x in such a way that x will be filled in and either a or b is going to disappear. So for instance, if I pick x equals 4 and I put it in here, this whole thing is going to be gone. So on the left side, I'm going to have 4 minus 4. I'm going to go ahead and spell it all out so you see it. Okay, so the whole idea here is this is now 2 equals 0 plus 4b. So, okay, just caught my typo, my righto. Okay, go back to the original problem. That's a 12. Tracking it through. Since Leslie's sitting here, she'll know this ahead of time. She's in the know. So all of these are 12s. Okay, and that fixes that to -8. I saw that fraction coming and I knew something was wrong. All right, so b is -2. We're going to do the same idea, only this time we want this one to go away. So in order for that to happen, x would have to be 0. So again, I'm filling stuff in. 0 minus 12 equals a times 0 minus 4 plus b times 0. So this is -12 equals -4a plus 0. Okay, so that went away. So a is 3. Okay, so just a reminder that a was the numerator for x. So this right here is going to be 3. And b was the numerator for x minus 4. So this right here is going to be -2. Okay, so I'm going back up to that problem I was working a minute ago. Okay, so the numerator for x is 3. Here we go. 3. And I think the numerator for x minus 4 was -2. Yep, there it is. Okay. Okay, so how does that help us? Okay, I mean, that was the new thing right there. What we just did was the new thing. All right, so I'm going to take this new found sum of two fractions, and I'm going to split it up. I'm going to write 3 times the antiderivative of 1 over x minus 2 times the I need a dx in there, minus 2 times the antiderivative of 1 over x minus 4 dx. Okay, and these are fairly straightforward to do. So 3 natural log of x minus 2 natural log of x minus 4. Now, quick little reminder that if the derivative of this, I mean, technically what I'm doing is a u substitution here. I'm not writing a lot because I noticed that the derivative of the u would just be 1. So I'm okay with that. If the derivative of this was going to be something else, then I'd be a little more careful with my u substitution there. Okay. So this is done. Now I am going to rewrite this in a little fancier form just because you know how it works with multiple choice and stuff. Remember, properties of logs say you can take these numbers out in front and put them back in. So this is natural log of the absolute value of x cubed and even more when you're subtracting logs, you can actually change that to division because logs are exponents. Excuse me. And the absolute value bars in the bottom really aren't necessary because you're squaring. All right, so I'm okay with the first one I boxed. I'm okay with this one. I'm even okay with the one in between. Okay? Partial fractions. Let's do another example. Oh, too much to see so far. All right, so here's another example. And again, the quick things you want to look for, I mean, I know it's partial fractions because I picked out the problem, but it's not just a normal antiderivative because this is obviously way more complicated. It's not u substitution because the derivative of this denominator is not in the numerator. We'd be looking at 6x minus 5, and there's no way to factor that into 6x minus 5 or anything like that. So next plan is hoping for partial fractions. Okay, so let's do a little bit of factoring of the denominator and see what. Oh, the other thing we'd have to check too is note the degree of the denominator is less than the degree of the numerator. Okay, so since that's true, we can proceed. If it wasn't, we would have to do division, like long division or something. Okay, all right, so let's try and factor this bad boy. 3x and x, I would guess. This tells me the signs are the same. They have to both be minus. I need factors of 2, and I need it when I go ahead and do the foiling or distributing that I add up to -5. So I'm going to guess 3 times -1 and -2 times 1. And I'm pretty sure that works. Okay, and then going from there, then we are going to take this apart and write this as 2 separate fractions, one with the denominator 3x minus 2, one with the denominator x minus 1. Okay, all right, so let's just kind of off to the side somewhere. I guess we'll just pick a spot. We're going to do this. So 1 minus 3x over. I probably didn't give myself enough room, but oh, that's a 1. Okay, equals a over. Okay, so this is not part of the normal flow of the antiderivative. This is us doing some playing around with it. Okay, so I'm going to multiply both sides by this denominator. So this is going to be 1 minus 3x equals like so. Okay, so now I'm going to be sneaky. I'm going to say, well, let's let x equal 1 because my goal is to find a or b, and I have too many variables floating around here. So if x is 1, then this is going to become 1 minus 3 times 1, so -2 equals, this is going to go away, and then I'm going to have 3 times 1 minus 2, so 3 minus 2 is 1, so this is just b. Sweet! All right, so b is -2. Okay, let's do the same idea again, only we want to make this thing equal to 0, and that's a little more tricky, so we have to do something like 2/3. Okay, think about the 3's cancel out, and then you have 2 minus 2. If you need to write a little equation on the side and solve it, do it, but you need 3x minus 2 to equal 0. Okay, so here we go. This thing is going to go away. On the right side, I will have 2/3 minus 1, so this will be a times -1/3. Okay, and then if I put 2/3 in here, this is going to be 1 minus 2, so -1. Okay, well, sorry, I don't have a equals yet, so a equals 3. Okay. All right, so with that in mind, Okay, so the a was the numerator of 3x minus 2, so I'm going to put that right there. And the b is the numerator of the other one. I'll put that right there. Okay. All right, so wrapping this around. I'm going to rewrite this a little bit. So 3 times the antiderivative, this is how I would normally rewrite this. It's just easier to see the 1 over when you write it like this. It's not the only way to write it. Okay, now I mentioned earlier this little detail of I'm thinking about this like 1 over u. But the problem is, if this is u, then du dx is 3. Okay, so this is my little side thought here. So this, I could have left that 3 in the numerator, and some people do it that way. I'm not gonna, because I've been doing it like this. This will be du over 3. Okay, so that was a quick little u substitution in the middle of this. Okay, now the antiderivative, I'm sorry, if I think of this thing as u, the derivative of it's just going to be 1, so I don't really have to worry about that. Okay, now these divide out. I don't want to write it 27 times, so I'm just going to go straight to the ln of u minus 2 times the ln of x. Sorry, that was supposed to be a minus. Plus c. Now, just a reminder, if you were going to be substituting values, then we wouldn't write the plus c. We would just start substituting values. Okay. All right. I'm happy camper right here. I'm also going to rewrite this as ln of 3x minus 2 over, this is going to be x minus 1 squared, and the absolute values need to still stay on the top. Okay, so I like that one also. Okay, so what I'd like to do is a couple of things. First up, I want to point out this. Let's take a quick look at this. This looks like it factors, but before we do that, notice that if I take this denominator and do the derivative, its derivative is present. This is really not partial, not partial fractions. This is really u substitution. Let's take a look at these. I am thinking this is 2 times x plus 3. Nothing's going to divide out. This is x minus 3. Okay. And if I do 2x minus 3 for its derivative, that's not here. So this looks like a partial fractions problem. Okay, just to point that out. Okay, and then I actually want to do, I'm not going to do either of those. I actually want to do just one more example, at least start it. And the reason I want to start this one is I've been talking about the degrees, and notice this degree is not more than this degree. So that's a problem. Okay, so that means I'm not ready to do partial fractions on this yet. I actually have to divide first, and I know you'll love that. And it's not just a linear on the bottom, it has an exponent, so that means you have to do long division. There is an x term that's missing. I mean, technically this is supposed to be x squared plus 0x minus 9, and this would be x squared minus, or plus 0x minus 6. But because both of them are missing those same terms, we can actually get away without adding in those 0x terms. Okay. Looking at the first term, x squared times what is x squared? 1. Distribute, so 1 times x squared, 1 times 9, so x squared minus 9. And then remember you have to subtract, so I'm going to change both signs, and this is 3. So that means this bad boy is really equal to the answer from the division plus the, the answer from the division, 1, plus the remainder over what you were dividing by. So I just made a replacement for that. So this is going to be equal to the antiderivative of 1 dx plus 3 times the antiderivative of 1 over x squared minus 9. Now, I normally would pull that out, and I just did, but I do remember that the a and the b thing are going to work out a little nicer if I leave it in, just because they won't be fractions, I believe. Okay, so from here on out, the first part's easy. The antiderivative of 1 is x. The second part, you're going to have to split that up into x plus 3, x minus 3 dx. Okay, and so after this, the rest of the work kind of follows, and in the interest of time, I'm just going to write it down, and you can decide what you want with it. Okay, so this is after the partial fraction stuff has happened. So I multiplied by the denominator to clear them. I substituted specific strategic values in to make the a go away and then the b go away, and then I solved for the opposite one. Okay, so the b, the number above x minus 3, is 1/2. Now this looks really crappy, but it's really not that big a deal, thinking about what we're about to do with this. Okay, so that's what it looks like. And all I'm going to do is split this up, and I'm going to pull these numbers out in front anyway. So it looks kind of cheesy having the plus and negative, so I'll fix that. Minus 1/2. Okay, and we're almost done with this now. X equals, so equals x minus 1/2 ln. Now again, the derivative of that denominator is just 1, so I don't have to worry about it being present there. Ln x minus 3. Okay, and so I'm, as you know, if you're just writing this, I'm good. Now keep in mind again, if there were numbers to substitute, we would have to do that. Okay, and then one more time. X, let's put this plus ln the square root of, okay, and you're going to have to think about why the x plus 3 is on the bottom. Okay, and I know there's some absolute values that need to go there, and I think that I can make this work by just putting it right there. Okay, all right, well, that's enough. Partial fractions, that is the first half of 6.5. At this point, 2014, we are not going to do the second half, so don't go hunting for a 6.5b at this point. We're not going to do the logistic growth stuff. So, thank you very much for watching, and we're out. Bye.